Hi, my name is Vladimir. I'm working at Akiva Labs, and today I will show you how we can automate error reprocessing of any Scribe solution. As you know, failures are unavoidable parts of any technical system. Of course, we should do our best to design solutions with failures in mind, but in case of transient faults, sometimes it's really difficult to implement elegant recovery. And all we can do is reattempt and hope that connectivity is restored. Consider the case when you have an unstable Scribe solution which sometimes succeeds and sometimes fails. Scribe Online provides an ability to reprocess failed errors, and here how you can use it through Scribe Online user interface. As you can see, you can select each error and reprocess only the selected ones, or also you have an ability to reprocess them all. But actually you want to automate this process somehow, and in this video I will show you how you can do that. As a prerequisite, you should have an unstable map. I have following one. This map will only succeed in 50% of the cases. In the first half of any given minute it will fail, but in the second half it will always succeed. Let's see how I implement that. We're using fictive entity called select1 from Scribe Labs tools connector. It just provides a single row with current datetime in it. It can be very handy if you just want to start the map without querying any external data source. If block checks the seconds part of current datetime using datePart function and compares it with 30. Here we get the 50% of success rate. Actually, you can replace 30 with other value if you want a different success rate. In the else clause, we put an execute command with dates entity, which will always fail because we put invalid values to target connection fields. As you can see, these values are obviously invalid because it's really not datetime and not integer 64, and execution of this block will always fail with some kind of parsing error. After you finish with the unstable map, you should keep in mind ID and organization ID of this solution. You can get them from browser's URI. For example, here we can get the organization ID, and here we can get the solution ID. Okay, let's move on to the solution which implements the error reprocessing logic. We implement this solution step by step, so you will understand each particular block from the final map. Okay, let's see how we can automate error reprocessing. First of all, we should retrieve execution history from Scribe Platform API. For our purposes, we just need the latest history entry. And that's why we sorting by start column in descending order. Before we can reprocess errors, we actually need to distinguish between successful and failure histories. For this purpose, we have if-else block with given condition, which will filter out histories by result value. The reprocessing consists of two parts. The first part is the mark all the errors. We implement this part using command block from Scribe Platform API connector, and we just use the IDs from the root block. And also we want to mark all the errors for reprocessing. The second part is reprocessing itself. Here we're also using command block from Scribe Platform API connector, but with different entity called reprocess all errors. In target connection fields, we also use the IDs from the root query block. And actually we implement the basic solution, but if you want to add more robustness, keep watching. If you want to have more attempts for solving errors by reprocessing, we can add retry logic into the map itself. However, it will require to refactor our map a bit. So let's switch to the second version of the map. You can see that it's a little bit longer than the original one. Let's see the differences between them. Let's set as an active stack the second version of a map. On every retry, we want to work with latest execution history record. That's why the initial query history block decomposed into two. The new root query block works with solutions, and this block will always return just a single solution because it uses IDs in its filters. The second block will look up the history. Actually, it's pretty much the same query block using almost the same filters, but it took the filter values from the root block, from the new root block. Also, we added a loop with an if-else clause to implement retries. Retries implemented by using seekNum function. So this function is a retry counter, and it will return the next value incremented by 1 each time it's called. The counter will be automatically reset after each map execution. Okay, we implemented basic retry functionality. Straightforward retries can be one of the sources of accidental denial of service. To avoid this pitfall, we can implement truncated exponential backoff algorithm. It's not that hard as it sounds. The idea here is to exponentially increase delay time between retries until we reach maximum retry count. So, delay on each retry will be computed as 2 in power of retry counter. Optionally, we can add some amount of randomness here when we compute value of delay time, but it's not needed for our case. Currently, Scribe Online doesn't support power function, but we can emulate it with other smart technique called memoization. So, the idea is pretty simple. We just pre-compute power of 2 and stores them in some place. And the ideal place in Scribe Online is lookup table. In my organization, I already created lookup table called powers of 2, which contains obviously pre-computed values for power of 2. And with help of Scribe Platform API connector, I can use these lookup table values directly in my map. Now it's time to switch back to Scribe solution. Here I will use the new fresh feature called map revisions to switch back to the revision of a map that I need. The final solution implements the exponential backoff, and for this purpose we changed just two things. Instead of seqnum function, now we're using seqnumn function, which provides ability to name the sequence, so we can use it from multiple map blocks. The if block is the first block that uses this named sequence, and after that we can consume this value in each of the above blocks. Also, we added a new block from Scribe Labs Tools connector. It's the execute block with sleep entity, which suspends the work of a map for a given time in the milliseconds. Here you can see the formula that reads the lookup table value that already exists in my organization, and it will use the sequence number from already created named sequence. And it's time to execute the map. In this workspace, in the above window, you can see the error reprocessing solution, and in the below, you can see the unstable solution. Each time I will execute the error reprocessing solution, you will see that unstable solution will be scheduled for reprocessing. Now you can see that latest execution history failed with some record errors. Now it's time to check our implemented reprocessing automation. So let's run the map. Before that, we should validate the map and apply all the changes. Let's wait while Scribe prepares the solution. And now we will have an ability to run it. So let's wait for reprocessing of unstable solution. So the first attempt for reprocessing is failed. The second one also failed. But the third attempt was successful. So, in this video, you learned how to mark and reprocess all errors from particular solution execution with help of Scribe Platform API connector. And also you learned how to implement retries with Exponential Backoff to prevent accidental denial of service with help of sleep block from Scribe Labs Tools connector. And also you learned how we can overcome the absence of power function with lookup tables. Thanks for watching.